part 2 of session 2, we're going to look at switches and circuits. At the end of this part of the session, I want you guys to be able to, identify each type of domestic electric circuit from a description and recognise it from a picture, draw the symbol for a double pole switch, and identify various switches. Firstly, we're going to look at radial circuits. This is the first one of 2 circuits we're going to look at. A radial circuit is a circuit that would go out from the consumer unit without returning to it. As you can see here on this radial circuit to the sockets, goes out to the sockets, it doesn't return from the sockets. A ring main circuit. A ring main circuit is one that does return to the consumer unit, and because it's connected, both sides are connected to the consumer unit, it can cover a much larger area and take a much larger load than a radial circuit can. A couple of key facts about the ring main circuit. Ring main circuit in most modern consumer units would have a fuse rating of 32 amps, which means its power, the power consumption, the load that it was taking, should not exceed 7.2 kilowatts or 7,200 watts. Another key fact, ring mains should not cover areas greater than 100 meters squared. And that's why, actually, quite often, if a property has got more than one floor, you'd have a separate ring main circuit for the upstairs and for the downstairs, like you can see here. So sockets at the front, sockets, there's other sockets over here as well. There we go. Okay, the cable. Okay. The cable that you'd use for both radial and ring main, if it's feeding the sockets, would be twin and earth cable. Sometimes it might be described as twin and CPC sheathed, because you need to add sheathing to the earth wire. And as you can see here, it's got the brown wire here, which we know is the line, blue wire here, which we know is the neutral, and the CPC, or the earth wire. CPC stands for circuit protective conductor. You might often see it as CPC instead of earth. It's unsheathed, it doesn't have anything on it, so we would need to add insulation, add a sheath to this to make it safe whenever we connect it. So ring main uses 2.5mm twin and earth cable. Spurs. Briefly talk about spurs. Spurs are essentially an offshoot from an existing circuit. You're normally allowed to take one spur off any socket. You can't take any more than one spur off a socket. You can see here, I've got a spur taken off just here. To prevent the system becoming overloaded, you should not take more than one spur off any circuit, so we don't take an extra spur off another socket. Okay. Bit of key information: appliances that have got lower power requirements, for example, boilers, gas boilers, because they only really need very low electrical power consumption, just to light the boiler really into say, keep the lights on essentially. It doesn't. You can take that as a spur off of the ring main. Also, you can shower pumps, gas boilers, extra sockets could all be sort of spurs off of the ring main. If we did take a spur off the ring main, it would need to go through a fuse before the boiler, and that fuse would be 3 amps. Worth remembering, because they like to ask that in the questions. Okay, you'd run off the same voltage as the rest of the house, 230 volt AC, alternating current. Okay, you can see here a fuse switch spur for the boiler. Space here for the 3 amps fuse. Also a switch to switch the boiler on or off. You've got here one with a neon, which would let you know if it was on or off, and another one without a neon. So one's a fuse switch spur with a neon, the other one's a fuse switch spur with just a fuse switch spur. Okay. So unswitched spurs should be used with appliances which should not be turned off. And the prime example of that is a macerator WC. A macerator is essentially something that you'd fit on certain toilets which are a long way away from or underneath a drainage pipe, essentially. And what a macerator does is it kind of blends up whatever is put into the toilet and will then pump it to an appropriate place. And we really don't want that to be able to be switched off. So what we would then do is we would fit an unswitched spur, fuse spur to these. Okay. So yeah, we can see an unswitched spur with a neon up in the top right here, and a fused switched spur underneath it, just there. This is the one we would not use for a macerator, would use that for a boiler, for example. Okay. Briefly look at high voltage appliances. Certain sort of high voltage appliances like cookers and immersion heaters and electric showers, because they draw a large load, would need their own connection to the consumer unit. Okay. They would also have a fused switch spur near the appliance itself for isolation. Okay. But if you were going to work on these, the best place to put it is at the consumer unit and lock it off, and also isolate it at the closer point as well, to be doubly safe, I suppose. Okay. Bit of interesting information here. These appliances that are drawing large loads should have a double pole switch. And a double pole switch would switch off both the line and the neutral conductors. And the symbol for this you can see in the right hand side here. Appliances in bathrooms are high risk appliances because there's a lot of water there. And therefore we should keep switches outside of, ideally outside of the bathroom. There's some interesting information about zones in bathrooms, which we could maybe talk about in the class if you guys are interested. But generally speaking, as a rule of thumb, we'll keep all rocker switches outside of the bathroom and use pull cord switches inside the bathroom, which means that wet hands aren't going to come into contact with the actual switch itself. You can use low voltage shaving sockets in the bathroom, but that's because they are low voltage. They're not really a significant risk. Now it's time for you guys to do your task.